Thanks everybody for showing up today. I know there's a coffee break immediately after this, so I won't be offended if you fall asleep. That's all right. You can always catch the recording later. So we're going to talk about the CNCF Tag Security and Compliance Software Supply Chain Security Best Practices Guide, which is a very long title. It was updated this year, and so we're going to talk about the new and exciting things and kind of a review of where we came from. So I'm John from ControlPlane, and I have to give credit to all of the other authors of this paper as well, too, because there's a lot of work that went into it, a lot of time and effort. So a little bit about me. I think we should all share a little bit of our failures. So I dropped out of college twice. Went to 5 different colleges eventually before I got a degree. As I said, I'm a security consultant at ControlPlane. We focus on cloud-native security, Kubernetes, and supply chain security, and many other things. I'm an open source maintainer for the Witness and Archivista projects. They're sub-projects underneath Intoto, which just became a graduated project this last year. SBOMs is a project in OpenSSF and the update framework. I'm also a tech lead for the Tag Security and Compliance and a contributor across a few other projects. All right, so where did it all start? Anybody remember what this timeline is from? This is from the solar burst, the original SolarWinds supply chain attack. So we can see all the way back in 2019, kind of the initial access to the build infrastructure that started the whole chain of events leading to the compromise, eventually its discovery, the investigation, and the findings, which January 11th, 2021. And going back to the original draft of the first supply chain document, January 23rd, 2021 is when this working group started within the tag security group. So the original guide kind of laid out 4 key principles for the best practices for supply chain security. And the first one is really the idea that it should be a chain, which is kind of obvious. For every step in your supply chain, you have the inputs, you have some process that happens, a build process, a testing process, and then the outputs. If you don't connect the inputs and outputs from one step to the next, if you don't have trust between those different steps, trust in the transfer of the input or output from the step itself, then you don't really have a supply chain. You just have a bunch of arbitrary things that happened, and you don't know much about that. One of the things that's, I think, a key general theme of the update is the amount of tooling that has been created since then. So the original principle here, almost everything has a caveat from back in 2021 that there's a manual exception of you should automate all of these things as much as you can. However, if you can't automate the definition in this case of trust relationships, you should make sure that they're explicitly defined. All right, and so the second key principle here is automation. So like I just said, humans, they're error prone, they miss things, there can be configuration drift, depending on the environment, depending on the systems you're using, things change over time, and hopefully all of those things are codified and you're continuously running this automation so you can check things again and again and again. CVE databases update if you're doing vulnerability scans, tooling improves over time. You should make sure that you're always doing these things, and that will help identify things like configuration drift or other things that maybe are not codified, or if there's a compromise to the system as well too. All right, and then the third principle here is about build environments, and so the build process is arguably probably one of the most important parts of your supply chain. And a couple of key things here that were much less common a few years ago. The idea of having machine identities for all of your build infrastructure, even really simple things such as treating your build environments as production environments, having restricted access, having the minimum permissions needed in those sorts of environments. These are all important things. All right, and then authentication. You should have to log into all of these systems or possibly not even be able to log into them. If you're using keys for them, the keys eventually will be leaked or compromised or something will happen. Certificates will expire. Be prepared to rotate all of those things. And here was our glorious architecture diagram of a sample supply chain. So you can see here at the beginning, your source code, your dependencies going into the build systems, some engineering development process happening. Then you produce an output that is sent over a network somewhere to an application repository, and then eventually, hopefully, deployed. And not all software we write code for is used, but ideally, eventually someone uses it. So this is a pretty simple idea of the supply chain. And kind of as we said here, if you go and read the guide, you can, it's 30 pages long, all the exact details of securing each step here. And so we kind of laid out securing the code, materials, the build process itself, the artifacts that are produced, and the deployments afterward. For each of these sections, we looked at kind of these broader themes of how to verify these steps or the security of them, how to automate things around that, and then the authentication and authorization. So we did all of that, and how did it go? There was a lot of really good progression afterwards. The original white paper eventually then led to the Secure Software Factory reference architecture. There was a reference implementation of the reference architecture called Fresca, which was the factory for repeatable, secure creation of artifacts, which is another thing that is a complete mouthful. That's a project under OpenSSF, so it's still there today. You can go and find more information about it. In the US, we had Executive Order 14028, which was the an initiative to try and improve the security of software. And there were two main things that came out of this, and one was SBOMs for everything. Anyone who sold software to the government needed to provide an SBOM. The other was what eventually became the SSDF, which was the Secure Software Development Framework. And this was laid out specifically in NIST 800-218. They cited the CNCF Supply Chain Best Practices Guide as part of how they laid out the different controls that were established as a part of the SSDF process. So that was really, really cool to see. And then there was eventually a follow-on created and released just last year, NIST 800-204D, which was written by Santiago Torres, a professor from Purdue, and Frederick Kautz from TestifySec. And that really went into how to apply supply chain security best practices for CI/CD in a way that was kind of standardized and formalized. So this is a much more complicated picture. This is kind of taking that original simple supply chain security picture, and this is from the Fresca project itself. And so kind of looking at this architecture here, you can see the Git repository at the top left, the developer interacting with that, and that's the input to this process. And so in this case, the reference architecture used Tecton to have a pipeline run that was triggered by the source code, which then had a series of task runs. Each of these task runs were observed by Tecton Chains, which was connected with Spiffy Spire, so it was able to establish the identity of the tasks as they were all started. So you knew the task you wanted to run and expected to run was what was actually executed. Then Chains would create an attestation for that activity happening. And then there was also an admission controller to be able to kind of verify all of those different bits and pieces came together the right way. So that was kind of what happened afterwards and what's going on now. So we had this great best practices guide. Everybody followed everything, and we no longer have to worry about supply chain security, right? It's a solved problem now. Not quite. So last year we had XZ Utils, which was kind of really long, drawn-out, what we later found out was a nation-state attack against a really commonly used open-source library. And so there was a social engineering campaign against the maintainer who was getting burned out and overwhelmed to basically say, you know, we need your help, fix all these things, do it now, this is really important, it's super critical. And this really nice guy came along and said, I'd be more than happy to help out with your project. And it turned out that he helped out with the project and then some, and ended up putting a backdoor into the code as a form of a binary in the build output itself. But it wasn't in the source code. And so it was another one of these things that took a long time, and I think one of the questions then was, if this started 2 or 3 years ago, how many things have started since then? How many are going on right now? And we have no idea that they're happening. We'll find out eventually. XZ Utils was found out from an engineer at Microsoft doing some performance testing, and the great part about open source, they were able to go and look and see, these things don't match up. Doing some performance testing, all of a sudden, where is it, where is the performance bottleneck? You can run profiling tools and see it's in this library. It's doing something weird it shouldn't be. And then eventually they were able to find out before the library was widely consumed. Another one here, TJ Actions changed files. This is kind of a really good reason why you should be pinning. Most all of your dependencies, GitHub Actions in particular, in this case, they went back and changed the tag itself, so it pointed at a compromised version of the action. So rather than running the version you expected, it was running a malicious version. Last, I think Thursday or Friday, this is super new. Someone is typo squatting ghrc.io, which is not the GitHub container registry. You can see they switched the C and the R. It has implemented just enough of the OCI specification to allow you to do a Docker login. And it will take your credentials. So if you have mistyped this somewhere, it will end up intercepting that, and we don't know what it could do. We're just sitting there and waiting. I'm not sure if anyone has found out what the origins of it or where it's going, but hopefully someone will take care of that. Until then, though, it's just sitting there collecting who knows how many credentials. And this is expensive, right? So in 2023, $45 billion. In another year, could be up to $80 billion. It's a lot of money to spend having to deal with the fallout from these supply chain security attacks. So we're seeing, though, as an industry, as an open source community, a lot of really good response to this as well. So a lot of the open source repositories for PyPI, Ruby gems, Node modules, Rust, they're all adopting things like trusted publishing, using things like Salsa build provenance to be able to prove the origin of the packages that are being distributed through those repositories. PyPI and RubyGems are adopting RSTUF, which is the repository service for TUF, so that you can protect against things like when you mirror repositories, you can ensure that you don't have a malicious mirror that's serving altered or manipulated content, and it has a bunch of other really important security guarantees. We're seeing broader adoption of the SigStore project, signing container images, creating attestations. You can actually see on GitHub itself now, if you go to a lot of different projects, I don't know if there's a link from the UI yet, but you can do /attestations and then see a bunch of attestations that are produced depending on the project. The homebrew one is a good one. You can go and see that they have attestations for every single bottle that's created. They also, when you do a brew install, will automatically verify that implicitly. And that's been a really important way for getting real-world adoption of this, is for the tooling to just build it in. So you may not have known that, when you do a brew install, it's also build provenance is being verified and attestation is being verified, but it's happening. So the new guide, we got better diagrams, yay! The one thing I will say about this is actually the SALSA diagram for their threat model. And anyone who's seen a supply chain security talk since the SALSA group came out with this, it probably had some version of this diagram in it. If you are a vendor and I've seen you present this with your own color scheme and you did not credit salsa.dev, please just credit them, because we all recognize that we've seen it in enough places. It is open source. You can take it and use it without doing that, but we know who you are. So looking at the new paper and looked at the differences in some of the terms that were cited in the paper. So identity, we had an increase. This is the increase in the number of times that term showed up, was 10 more times than previously. This is largely due to an increase in the references to workload identity, machine identity, things like being able to use those short-lived identity tokens to sign things, especially because of SigStore's Fulcio, to be able to use that to create signatures. VEX didn't exist when the original paper came out, so this is an increase from 0 to 20. VEX is a vulnerability exchange document, which pairs well with SBOMs, also improving or increasing in the reference. The idea of SBOMs was around back in 2021, but there was not a whole lot of tooling to really support that. Policy is another one. We have all this extra metadata that people have been generating. What do you actually do with that? You have to verify it in some way, and that's where the policy piece comes in. And attestations. This is, I think, another hugely important part. Every single one of these other things should be created, the metadata stored and shared in the form of an attestation. And we have just a couple of more open source projects that exist now that didn't exist 5 years ago. So we can see some new projects under the in-toto space, things like SBOM, Witness, Archivista. SALSA is an in-toto attestation. Under TUF, we have RSTUF. There's another project I don't have on here, TUF on CI, which allows you to much more easily create TUF repositories through CI systems. That is what they use for the SigStore root of trust. As they update it over time, they'll have a new run of the GitHub Actions pipeline there that creates the updated version of their TUF root and the other pieces of metadata associated with that. Guac is a project that can take in your SBOMs and other pieces of supply chain metadata and create a graph out of them, which can be really helpful for understanding the relationship between dependencies and the different inputs to your software. So you can see here everyone is using the exact same version of this library, and there's 100 references to it, and then here's another library that's been typo squatted that one team is using, or that maybe is an old version that one team is using. And then there's a whole suite of SBOM tools here under OpenSSF. On the left, this is actually OpenVex, so it's a specification for AVEX document, vulnerability exchange document. And then there's Protobomb, which is a sort of intermediate library that was developed to be able to more easily translate between things like CycloneDX and SPDX and back and forth, because really, in the end, as consumers, we don't care about the standards. We just want things that we can use. It's good to have the standards so things are interoperable, but Protobomb helps to deal with that interchange. BOMCTL is the next one here, is this sort of farmer icon. This is something that can take SBOMs and combine them or partition them and do different sorts of operations that are really useful as you're building and composing software. You're pulling in all these dependencies that have SBOMs. You're producing new software that's going to have new SBOMs. And so that helps to aggregate and kind of compose those. Next one here is S2C2F, which is, for some reason, we always have these really long names in software supply chain security. That's the Secure Software Consumption Framework, which goes into more details about how you should decide whether or not to use a particular dependency as you're consuming it and then producing more software. And then we have GitTough, which allows you to create more policies around securing your Git repositories to ensure you have things like signed Git commits, you have branch protections enabled, you have the right people committing code on a branch and then merging that branch into main after you have appropriate number of code reviews. And one of the really cool things about GitTough is storing all that information in the reference state log that's a part of the Git repository itself. It's not specific to GitHub or GitLab or any other SourceForge. And then the whole suite of SigStore tools. So in the new guide, one of the things that we did is we learned that, or we saw this evolution, supply chain security was not just one person's responsibility. So we had a section in the beginning, kind of how to read this guide, and it was laid out by persona. If you're a developer, where should you start? In the case of developer, you probably could improve your dependency management, or if you think it's good, just ensure you're doing it the right way. You're updating dependencies that are vulnerable. You're doing all of those sorts of things. You're actually looking at the dependencies you're pulling in and thinking about, should I use this open source library or not? If you're the security team for someone producing software, help your developers do the right thing. Give them guidance on how to write secure code or do code reviews, different things like that. If you're an executive, are you actually measuring anything? Do you know what software is being used where? Are you asking the right questions? As a platform team, how can you build supply chain security into the platform you're offering? If you're consuming software, how can you make sure that you're actually verifying it? And as an end user, are you actually making an explicit choice about how you're consuming your software? Not necessarily a supply chain security attack, but CrowdStrike is a great example of this. If you have software that you're running that just automatically updates, and that software includes a kernel driver, and that crashes every system and every computer you're running because that kernel driver corrupts the memory, you're going to be in trouble. So you need to think about these things, and also ask your vendors, ask whoever's selling you software to ensure you have that control. So in the overall guide here, you can see most everything is the same. We're still talking about code, materials, build, artifacts. We also added distribution and deployments as a part of it, slightly expanding that. For the themes, we talked about controlled environments. So this is more for the code and build and artifacts. What are the sorts of permissions that should be there? How should you be restricting access to source code repositories? Who should be contributing things? The same thing with build infrastructure. Should you, can you be resilient to people who are administrating your build system from compromising the build system itself? If you're a developer pushing code that's being built and that system is operated by someone else, how do you even know what comes out of that is what you would expect it to be? And then authentication and authorization. This is much more slanted, once again, towards that machine and workload identity piece as well. So where you can do those things, we would strongly recommend that. So where are we going? We've seen, so obviously we didn't solve all the problems. There's still things going on. What can we, I think right now we're either there's a bunch of people here silently achieving everything and you're well on your path to supply chain security adoption, or we saw the peak of inflated expectations from the hype cycle a couple of years ago after everyone was responding to SolarWinds, and we very quickly went down into the trough of disillusionment. There are probably some set of tools that have already died off and have gone away, but we're also seeing, as we saw, new tools actually being adopted. So I think we're on the upward curve here, and really helping to, the attacks and the compromises. Some of them are still really basic. There's some new things like AI slop squatting, if people have heard about that, the idea that your code completion from AI is going to generate a library or dependency that is hallucinated. And so you can go and, just because someone keeps mistyping this, or you assume that dependency is really there because you didn't review it, you didn't check it, it's easier to take over those domains that other people never would have thought to take over because they don't make sense, but they do to AI, apparently. And we have further incentive to have supply chain security, right? Because really compliance is a way to force people to do security, because as much as we would like everyone to do security for security's sake, if you don't make it a penalty for not doing security, it's hard to get organizations and companies to spend the money on it a lot of times. So I won't speak more about CRA because you will have probably been talked to death about it already, but it is here, and we will have to deal with that. So the other part about what's next, come in and help out, learn more. This is a part of the tag security and compliance group. Recently, the CNCF tags were the so-called rebooted. This was to really help prepare. We had the 10-year anniversary of Kubernetes last year. The number of CNCF projects went from a handful of projects, a dozen projects, to hundreds of projects. And as they try to do things like move from an incubating or sandbox stage through to the more production-ready, formalized, graduated state, it takes a lot of time to review each of those projects. And they were hitting a lot of different bottlenecks for that. And so they wanted to kind of restructure things to distribute a little bit more of the process around improving those projects, providing feedback to them, and really making sure that the organization was able to support all these projects. So with that, we have a new charter that is proposed and is being reviewed by the TOC. There's a PR for this in the GitHub repo of the TOC right now. The big change is including compliance as a part of tag security and compliance. Originally, it was just tag security. So what that really means is sort of to be determined. So if you have strong opinions about compliance, we would love to have you show up and contribute and offer those. There's also a CNCF community group for supply chain security. This is part of that restructuring. There's a lot of, just conversations we could have every week about supply chain security. What was the attack you read about the last week? What's the thing that you're struggling with, the problems, the tools you're trying to use? How are you thinking about these problems? So that's more just conversational. You show up and talk about interesting things. And there is a GitHub issue looking for leadership for that. So it's really leadership for a community group is someone who's willing to show up and help organize the conversation, and make sure that everyone's adhering to things like the code of conduct. And there's not really a whole lot of responsibility for it. So, all right. And with that, if anybody has any questions, I think we have a little bit of time. Eddie, I don't know if you have a microphone or not. I can repeat the question for you.
What is the average engagement with all of the past work, and how do you expect people, the average person, to engage with the future work that you guys are doing on these topics?
So the question is, what sort of engagement in the past have we had, and what sort of engagement do we expect in the future? So I didn't have a show in the authors for the V2 of the Supply Chain Best Practices Guide. We had a citation of the original authors. The original authors list was like 40 or 50 people. It was a very large number of people. The updated version had, I think, less than a dozen. It was like 10 people who showed up. So it's definitely a few of us stuck around from 5 years ago until now. And as the sort of the maturity has increased, there's maybe less novelty to it, but there's still really exciting and interesting things happen. So we have had a little bit of a drop off maybe in engagement, but hopefully I'm optimistic, especially with the tag reboot, we can bring some more people in. We're really trying to work to reduce the barrier to entry and have a little more organization around how the new projects are structured so that they're, more easily, people can come and go as they want to be able to show up, contribute to something quickly without a lot of overhead. And then, we know how life is, how work is. Sometimes stuff inevitably always comes up, and you might not be able to show up and contribute for a little while, and that's okay. So, yes?
Is there any interest from the guys doing the CRA towards this initiative? Are they already some conversations or something?
So the question is about the interest from CRA around the Supply Chain Security Best Practices Guide. I think that we've seen a lot of interest generally around supply chain security and the CRA. There's a project, since Eddie asked a question, I'll point my finger back at him, called the Security Baseline, which is an OpenSSF project that lays out a set of controls around software security, and really broader than that is sort of about many of the different things that are covered by CRA. And last time I heard, I think 19 out of 21 of the CRA requirements are covered by the baseline itself. And so it looks at things like what open source licenses are you using as well, kind of not necessarily security things, but general considerations for consuming open source software. And I think as well, things like salsa build provenance, if you generate that, if you have a security insights file which shows or links to references where you're storing SBOMs, where you're storing signatures for your binaries, things like that, that all becomes part of, showing and representing the compliance with those controls. So. All right. Well, thank you all for joining. Go definitely get some coffee. And if anybody wants to chat more over coffee, I'm happy to do that as well, too. So thank you.